Okay, so these are notes for Pre-Calculus Honors 2.7, Solving Rational Equations. For polynomials functions f of x and g of x, rational equations can be written in the form of f of x divided by g of x equals 0. If f of x and g of x have no common factors, the zeros of f of x are the solutions of the equation. So, for example, take a look at number 1. We're going to solve this rational equation for x. Please pause the video and factor the numerator and think about what values of x would make this equation true. All right, so we know that 0 divided by a non-zero real number must be equal to 0. So when you factor the numerator, you realize that x plus 3 equals 0 or x minus 1 equals 0. So we have two answers. Now, we really should check the domain of the function. Notice x cannot be equal to 3. So negative 3 and 1 are solutions. Okay, here we go. Let's go ahead and take a look at the next example. It says, when we multiply or divide an equation by an expression containing a variable, the resulting equation may have solutions that are not solutions of the original equation. These are called extraneous solutions. For this reason, we must check each solution of the resulting equation with the original equation. So go ahead and pause the video again and factor the numerator and solve for x for number 2. So notice for this rational equation, if you just think about what values of x would make the numerator equal to 0, you would say x equals 3 equals 0 and x minus 1 equals 0. However, notice that if you check the domain, x cannot be equal to 3 because 3 would make the denominator 0. So 3 is extraneous and we end up with x equals 1 as our solution. Let's take a look at number 3. How are f and g alike? How are f and g different? Would the graphs of f and g look the same? Why don't you go ahead and factor the numerator for f of x and try and sketch a graph for each. Go ahead and pause the video, please. So if you go ahead and cancel x plus 1, the quantity x plus 1, from the numerator and the denominator in f of x, you would think, oh, that the graphs look the same. However, f of x will have a removable discontinuity. There will be a removable discontinuity at negative 1, comma, negative 3. And notice that g of x does not have a removable discontinuity. So their domains are different. Okay, so again, domain, all real numbers for g of x, and x cannot be equal to negative 1. So there is, they have some similarities and some differences. Why don't you go ahead and take a look at number 4. We're going to go ahead and find the domain and then solve algebraically and check for extraneous solutions. So go ahead and pause the video and solve for x. All right, so if we multiply both sides of the equation by x, the quantity x plus 4 and the quantity x minus 1, we end up with 4x times x minus 1 plus 3 times x plus 4 equals 15. So if we solve this equation, we end up with a quadratic equation which we are able to factor. So we end up with 2 solutions, 1 and negative 3/4. So go ahead and pause the video and decide if either of those or both solutions are extraneous. Okay, so notice since we multiplied by an expression that had a variable, we did create an extraneous solution. 1 is not is a restriction in our domain. So we had 1 solution. And if you wanted to think about this graphically, if you grab your graphing calculator, so I'm going to check this. If I go ahead and I could actually just subtract it to get 0 on one side of the equation over here. And if you take a look, if I wanted to solve this graphically, notice that negative 3/4 was an answer, but 1 was not, because you were looking, where does this equation, or where does this graph touch the x-axis? So there you go. You could look at this graphically. For the next example, we are going to consider a numerical method here. So notice we're going to look at a table. So if I say, this is a new problem, number 5, if I say 2 possible solutions to the equation, f of x equals 0 are 5 or 0. So in other words, in the resulting from the solving process, we ended up with these two solutions. And then we look at the table. Go ahead and pause the video for a minute. Would you be able to determine if 5 or 0 are extraneous solutions? So notice that x equals 0 is extraneous because you get an error, but for x equals 5, the y value is in fact 0. Let's take a look at another example. Now for number 6, again, two possible solutions emerge from the solving process, and I'm just curious, could you look at the graph and decide if either of those solutions are extraneous? Go ahead and pause the video and make your decision. So notice x equals -1 is extraneous because when you look at the graph, we're trying to find what are the x values when y is 0, and we have a solution at 1/2 but not at -1. Okay, so let's take a look at the next example. We're going to solve number 7, solve for x algebraically. So go ahead and pause the video and solve for x, and don't forget to check your domain. Okay, so if you multiply both sides of the equation by the quantity x times x plus 2, we end up with 3 minus x times x plus 2 equals 3x plus 6. So we have -x squared plus x plus 6 equals 3x plus 6. So we have 0 equals x squared plus 2x. So we can factor that. So again, from the solving process, we would think, well, x equals 0 or x equals -2. However, if you look at the domain, x cannot be equal to 0, x cannot be equal to -2. So we actually have two extraneous solutions. We have no solution. So what I would like you to do now is take a look at 7b and try and think about how, what do you notice about 7a and 7b? Are they similar in any way? Go ahead and pause the video and think about that. Okay, so do you see how for 7b, what we did is we looked at 7a and you subtracted 3 minus x divided by x from both sides of the equation, and we called that f of x. But now what we're going to do is think, what if that f of x is equal to 0? So if the answer truly is no solutions, then you should not have any values of x that make your y value 0. So go ahead and try and pick, if any of these, what could possibly be the graph of f of x, knowing what we know about 7a. So go ahead and pause the video and make your decision. Okay, do you see how a could not possibly be the answer, because you have, when x is 0, the y value is 0. And over here, again, that was an extraneous solution. And we know over here that when x is -2, the y value is 0. So again, that would not be a solution. But over here for b, we did not have any x-intercept. So b could possibly be a graph of f of x. And if you wanted to check that, I went ahead and typed this into y equals. And let's see what the graph looks like. And there you go. You could even check if you calculate the value, let's see, when x is 0. Notice that there is no y value, and again, the other value was -2. And there was no y value there. Okay, let's take a look at number 8. Go ahead and read the problem. Oops. Where did it go? Here we go. Go ahead and read the problem. We're going to do some application problems now. Go ahead and see if you can set up an equation for the concentration of the numerator. Okay, so notice that you have 100% acid. X mils of pure acid are added to 125 mils of a 60% acid solution. So notice the concentration would be the milliliters of pure acid divided by the milliliters of total solution. So let's do the denominator first. That might be easier for you. So notice that if you wanted to think about how much total solution you have 125 mils plus x mils. Notice that if you want to know how much pure acid, you have x mils of pure acid in the first beaker, but the second beaker, only 60% of those 125 milliliters are pure acid. The rest is probably water. So you have 125 times 0.6. So now what we're going to do is we're going to graph our concentration with respect to x, which is milliliters of pure acid. So let's just think about what this graph should look like before we grab our calculator. So notice that we want to have an 83% solution, which is possible if you add pure acid to a 60% solution. But wouldn't it make sense that you start off with a concentration, I don't know, I'm sure it's not zero, and wouldn't our concentration, as you add more acid, so the more pure acid that you are adding, wouldn't that concentration be increasing? So I'm expecting something like this. So let's go ahead and pause the video and use our graphing calculator. Okay, so again, it helps if you understand what you're really graphing. You're graphing the concentration, those are your Y values. Your X values are milliliters of pure acid. So if you think about it, the highest the concentration would be 100%. So that would be 1. So in Y2, we want it to be 83%, so that's 0.83. Don't forget that your entire denominator must be in parentheses. So X plus 125 must be in parentheses. So let's think about a window now. For X values, I'm not really sure how much acid I would have to add. But again, I'm thinking I would have to add, I already have 125 mils of 60%. So my guess would be, I'm thinking I'm going to need probably more than 125 mils. At the most, I'm thinking 200. So if 200 makes sense, I think I'm going to go to a little bit bigger, go to 250. Now for the Y's, again, this might be a little confusing, but you're actually going to go to 1 because, again, 1 would be 100%. So if we look at the graph now, there you go. So we want to find, again, it was increasing just like we thought, the more pure acid that you add. So if we find the intersection point, that will be how many milliliters of pure acid you would have to add to get an 83% solution. So 169.12. milliliters of pure acid. Go ahead and read this second application problem. We're going to have all rectangles with an area of 200 square feet, and X will be the length of one side of the rectangle. You need to describe the perimeter in terms of X. So go ahead and pause the video and write an equation. Okay, so we have a lot going on here. They're talking about area, they're talking about perimeter. So we know that you have a rectangle with length X and area 200. So the other side of the rectangle must be 200 divided by X. So our perimeter is 2 times X plus 200 over X times 2. So now what we're trying to do is find the dimensions of the rectangle with the least perimeter. Okay, so we're trying to find the least perimeter. So we're going to graph perimeter in terms of X. So let's go ahead and grab our calculator and type in this equation. Okay, so I went ahead and typed the perimeter into the equation, or into the calculator, in Y equals, and we have to think about a window. So let's first of all think about what values of X would make sense here. So if you think about it, the area is 200, so you could have a side that's 20 and 10, for example. That would, 20 times 10 is 200. So I think for my X values, I think I am going, if 20 made sense, I think I'll go a little bit bigger. So I think I'll go maybe 0 to 25. That within a window might work. And then the perimeter is the Y value. So again, let's say 10 and 20 make sense for X. So if you just think about this for a minute, if, for example, if you had X was 10, you'd have 2 times 10 plus 200 over 10 times 2. So again, this value would make sense if you had approximately 60. So let's go a little bit bigger and maybe make our Y max 80. Okay, so again, we're just kind of guessing at the window, and let's take a look at the graph. Wow, okay, so we need to find the smallest, that minimum perimeter, so the smallest Y value. So we'll go to calculate, minimum, and we'll choose an X value to the left of that minimum Y value and hit enter, and then choose a point to the right. And again, make sure you capture that minimum Y value because your calculator will return the smallest Y values of the choices that you give it. And then back up a little bit. So the minimum perimeter is 56.57 when X is 14.14. And again, our other side of our rectangle was 200 over X, which is 14.14. Not a surprise that the 14.14 feet by 14.14 feet, those dimensions will give you the least perimeter of 56.57 feet. Okay, go ahead and read the next problem, breaking even, number 33. Try and write an equation. Okay, so we are going to graph average cost of one hat with respect to X, which is number of hats, and this would make sense because you have $3,000 as your overhead. Even if you only make one hat, you still have that $3,000 overhead cost, and it's $2.12 per hat if X is number of hats divided by the number of hats. So again, this would be the average average cost of one hat. So I'm just going to guess at what the graph looks like. I'm guessing it looks something like this. Because if you think about it, if you make one hat, that's going to be a very expensive hat. The more hats that you make, the average cost should go down because, again, of those that overhead cost of $3,000. And we're going to let Y equal 2.75, $2.75, and we're going to try and figure out how many golf hats must be sold. Okay, go ahead and pause the video and grab your calculator. Okay, so make sure you put 3,000 plus 2.12x, that quantity in parentheses, divided by x. And again, we're going to sell the hats for $2.75. Now, we're kind of guessing how many hats do you think you need to sell? Well, again, $3,000 is a lot of money, and we're only selling these hats for $2.75. So I actually was thinking 4,000 hats, total guess, but I mean, again, and 5 would be big enough for the Y value. So let's go ahead and take a look at the graph. Okay, so you notice that wasn't even large enough. I should have gone bigger. So you're going to have to sell a lot of hats to realize a profit. So let's maybe say 5,000 hats. And if you look at the graph, now we could find the intersection. I probably could have even gone a little bigger, but I think we'll make it. So notice if you hit enter 3 times here, we end up with 4,762 hats to really realize a profit. That's a lot of hats. Okay, so here's the last problem we're going to do. Number 55, I want you to think about how you're going to solve for X. So we want X in terms of Y. So we have a complex fraction. And I think the first thing you want to do is multiply by some form of 1 that will, again, make this not a complex fraction anymore. So go ahead and think about what you would do. Pause the video. So again, you can multiply by a form of 1 whenever you want. So we could go ahead and multiply by 1 minus x. So 1 minus x times 1 is 1 minus x. 1 minus x times the quantity 1 over 1 minus x is 1. So this looks better already. So now we want to go ahead and we could add these two fractions, get a common denominator. 1 is the same thing as 2 minus x over 2 minus x. Now we can add two fractions since we have a common denominator. Okay, but we're still trying to get x on one side of the equation. So let's go ahead and multiply both sides of the equation by the quantity 2 minus x. So we end up with 2y minus xy equals 3 minus 2x. So let's get all of the terms with an x on one side of the equation and the terms without an x on the other side of the equation, and now we can factor out an x. So if you divide by the quantity 2 minus y, you have x in terms of y. Great job, everybody.